Let's look at the solution to our message passing versus shared memory quiz. If we have one core initializing an array and then all others reading the entire array, data distribution, the number of lines of code you need to do it in message passing is significant. The number of lines of code we need for that in shared memory is really 0 lines of code, because once the array is initialized in memory, others can simply read it. They don't need to really distribute the data in any way. In contrast, in message passing, the core that initializes the array now needs to send it explicitly to all the other cores, and the other cores need to receive it explicitly. So there is definitely more lines of code in message passing than in shared memory. Once you have the data distribution, for shared memory, you don't need to do anything for it. For message passing, you need to send and receive. Synchronization that makes sure that the array is initialized before we get to read it adds how many lines of code? In message passing, it adds 0 lines of code, because the sends and receives that we needed to do to distribute the data already ensure that until we receive the array, we cannot read it. So when we get to read it after the receive, we know that it's been already initialized because the send happens after the initialization. In shared memory, however, while the initialization is happening, the other threads could just begin reading it. So we need to add some explicit synchronization now to make sure that the readers wait while the initialization is happening. So we here have more than 0 lines of code. In this case, the message passing code is simpler as far as synchronization is concerned than the shared memory code. This is typically gonna be what happens between shared memory and message passing. Message passing needs to distribute data, but in doing so, it also synchronizes. Shared memory doesn't need to distribute data, but if synchronization is needed after the distribution, it needs to add explicit code to do that.